Hello, geometry. For some reason, it did not record. I'm like getting upset about this. Okay, I wonder if my flash drive is full. Might have to delete some of it. 8.5, properties of trapezoids and kites. Trapezoids, I can't tell you how important these are. You're going to see this a lot in calculus when you find the area underneath a curve using trapezoidal rule. In any case, I can use properties of trapezoids and kites, and I can use the properties of parallelograms in real world. Okay. So these two are not necessarily parallelograms. I should have changed this to quadrilaterals. Here we go. Yeah, let's just cut that out and change it to quads. So I know all the answers are on here. It's because I already recorded and I don't want to print out another set. Really hurting on paper today. And I'm not going to go out and buy them anymore. So here we go. Use the figure to answer the questions. So according to these two, they're parallel lines. Well, this kind of... No, is that going to help? No. Sorry, it's just too bright out. Remember, it works best when I'm working at night. Well, these are parallel lines cut by transversal. That means these two are same side interior, so they're supplementary. And that goes the same with these two. So 100 plus y equals 180. 100 plus x equals 180. Both your x and y are going to be 80 degrees. All right, this one, I don't think I have enough information there. It says if ax plus by intersect at P, extend both sides up, what kind of triangle is XPY? All right, now, we're making the assumption right here. I added this in. Without this information, you can't say it's isosceles, okay? Because you could have this. Then that's not going to be isosceles, okay? So obviously there's some information missing. I have to go look to see what I intended. I'll let you know. Ooh, vocabulary. Trapezoid. I think I fixed this on your notes. It's a quadrilateral with one. Okay, notice it's exactly one. So if you have two pairs, it's not a trapezoid anymore. It's now a parallelogram. The parallel sides are called bases. So if these are my parallel lines, this is a base, that's a base. And then the other two segments are called legs. Now, you have two sets of base angles. Notice I put one arc here, one arc there, but I put a line through it because I want you to know that these two are base angles, but they're not congruent necessarily. There is one case where they are. Same with these two. These are also base angles, but not necessarily congruent. Okay, show that ABCD is a trapezoid. So what I did is I found the slope, because remember it has to have one set of parallel sides. So I found the slope from A to B. I had to count up 2 over 4. And then from B to C, I had to count down 6 over 3. And then from D to C, I had to count up 4 over 3. And then from A to D, I had to count down 8 over 4. Notice that these two lines are the same slope. So I drew the little arrows right here. One set of lines that are parallel. So you have a trapezoid. Now the video is going to go a lot faster now. So if I'm going too fast, you have to slow down because I'm not writing anymore. Alright, this page has 3 theorems and then only one little easy problem. So here we go. Isosceles. A trapezoid is isosceles. Then each pair of base angles is congruent. Notice that these two will be congruent and those two are congruent. Those are the base angles because these are my two bases and they're parallel. Now if a trapezoid has a pair of congruent bases, so now if you have this, then it's isosceles. Then you have these. Okay? Then you know that these two are the same. Here, these two lengths will be the same if it's isosceles. A trapezoid is isosceles if and only if the diagonals are congruent. Okay? So these two will also have to be the same. If and only if, if these two are the same, then you know it's an isosceles trapezoid. So that goes, if and only if means they switch around. The theorem and its converse are both true. That sneaks up on a lot of people. A window shown as an isosceles trapezoid. And what I said last video is it would be horrible if you broke one of these because you'd have to get them all specially made, especially like that one, if you broke them because they're not perfect rectangles or anything. So this isosceles, that means this angle is going to be the same as that angle. Okay, they're both 115. And this angle will equal that angle. I found out that these are 65 because, remember, here's my base, here's a base, and they are parallel. So that means these two angles are supplementary. They're same side interior. Supplementary means they have to 180, so if you take 115 away from that, you get 65. So that's why those two top angles are 65 degrees. All right, last page. Hopefully you're staying warm. Today's your first day off for that cold weather. Last time I looked, the Weather Channel said it was 45 below wind chill. And we were doing experiments outside. We blew bubbles, and we put a soda can outside to see how long it'll take to explode. I watch it explode while I'm in here. All right, mid-segment. We talked about mid-segment with triangles, okay? Remember, this segment was half of that whole length. Well, this doesn't go up to a peak. So what you're going to do is you'll add your two bases and then take half. Okay, so DC is the top base, AB is your bottom base. Add them up, take half. This is kind of getting close to our area formula. So EF is the mid-segment. So to find this mid-segment, add the two bases, 8 plus 12, and then take half of it. Half of 20 is 10. Well, if you look at it, what goes in between 8 and 12? 10. Also remember what mid-segment does. It cuts this side equally in half, this side equally in half. Kites! Yay! Okay, you gotta be careful with kites. The diagonals are perpendicular. Okay, now I understand that a rhombus and a square, the diagonals are perpendicular. But also, definition right here, a kite is a quadrilateral that has two pairs of consecutive congruent sides, but the opposite sides are not congruent. So consecutive means next to. So these two are congruent, but opposites are not congruent. Okay? So if a quadrilateral is a kite, then exactly one pair of angles are congruent. That would be these two, not these two. What's nice is these two will be the same, and they all four add up to 360. So lots of times you're going to be finding one of those. In quadrilateral MNPQ, it's a kite. MN is congruent to MQ. MN is congruent to MQ, and then angle N is congruent to angle Q. We know that. All right. So, of course, naturally more properties. Last problem, though. It's a kite problem. Find F and G. Well, first of all, these two have to be congruent. So if that's 113, this one's 113. And this is a quadrilateral. All four add up to 360. So if you take 360, subtract 113, 113 and 44, you'll get that last angle, and that turns out to be a right angle. That's not always going to be the case, okay, just for this specific one, but that will be 90 degrees. Now, you've seen this little flow chart on the last set of notes. It has the properties of the different quadrilaterals that we worked with, and these are really important. So this is a nice document. I know it's scary when I say you got to memorize all of this, but when you start drawing the pictures, then you'll see it. Here's our homework. There's our Common Core Standard. Keep warm, and it was released just recently that you have no school on Thursday also. So please keep warm and try to stay somewhat productive. Have a good day. Bye.